Okay, so function A is in fact 1-to-1. So this is a 1-to-1 function. Okay. Now B, that's not something we spend a lot of time on. It is a graph, it is a function,
That's 5 minus x.
but is it, okay, you can't do that, okay? We are taking the square root of a difference. This is not the same thing as the square root of 25 minus the square root of x squared. That's two totally different things, okay? This, order of operations, PEMDAS, you have to do grouping symbols first. So before you take the square root, you actually have to simplify everything on the inside of the radical. Okay? So there's a slight problem, so you can't do that. That's a very, very common mistake. Okay? But that x squared is kind of significant there. What happens when you square something?
It multiplies by itself.
Okay? And what's the value of something that you square? If I square 3, what do I get? If I square -3, what do I get?
Positive 9.
Okay, so what's happening there? Okay. So, are we gonna have repeats here?
Yes.
Okay? Can y'all think of any value that x cannot be for this situation? I'm going back to a previous lesson now, asking now, we're talking about domain. Can x, okay, you're showing me a 5. We can talk actually. Can x be 5?
No.
What's 5 squared?
25.
What's 25 minus 25?
0.
Can you take the square root of 0?
No.
Yeah.
I can.
Yeah.
Square root of 0 is?
Zero.
0. Okay, so x can be 5.
So what about positive or negative 5?
Okay, what's -5 squared?
I don't know.
25.
25. What's 25 minus 25?
No, because that minus right there, it makes it a positive. So I don't know.
No.
Never mind.
And these order of operations are
How do
killing
you
me
make the
today.
first one? Hold on.
Here it is.
I was trying to do the I thingy. I don't
Yo,
know.
we can't graph eyes right now. We haven't done anything about that.
Well,
What?
yeah.
Wait, can you graph the eyes?
Yeah, we can have an imaginary
That's
plane.
scary.
Sure, we can do that.
Can you take the
My
square
brain
root of
hurts.
-50?
Okay. I'm not April fooling you.
Oh wait,
But
positive.
they perform so you don't know.
Can x be 6?
6, 36, 25 minus -36.
25 minus 36 is?
11. -11.
Can you take the square root of -11 in the real world?
No.
Mm-hmm.
So can x be 6?
No.
Okay.
So we could graph the eyes, whatever.
We're not doing that though.
In the real world.
Okay.
So that
So
was
if we were to graph this, if x was 5, you already told me that would be 0. If x was -5, you said that would be 0. What if x was 0? 25 minus 0,
25.
square root of 25.
5.
Here. So what this graph is doing is this.
So it can't be a 1-to-1.
Okay, sorry about the message.
Oh, you're doing so good.
I know. So, is that 1-to-1? Can it be 1-to-1?
No.
No, because
The Y's repeat.
y's repeat. Okay. So this is not 1-to-1. Okay. Y's repeat. It's not 1-to-1. Do y'all remember looking at graphs? There were multiple ways of determining if a graph was a function or not.
Yes.
Okay, one of the ways was does
Vertical
x
line
repeat, and then what?
Vertical line test.
Vertical line test, right? Now that we're talking about 1-to-1, is we want to introduce a horizontal line test. Okay, so to be 1-to-1, it has to pass the vertical line test to be a function. Then it's got to pass the horizontal line test to be 1-to-1. So you can clearly see that this graph fails the horizontal line test. Okay?
Wait.
And this graph passes both.
So it's a function, but it's not a 1-to-1.
This is a function, but it's not 1-to-1.
Okay.
Just like a parabola. A parabola is a function, but it's not 1-to-1. And we're going to talk about some other things about later on when we talk about restricting the domain. So at the bottom here, a function is 1-to-1 if every horizontal line intersects the graph of the function at most once. Okay? Capture it if you want to. We're moving on. So, pictures, is A 1-to-1?
No,
No,
A is not 1-to-1 because
y repeats
horizontal.
or horizontal line.
fails the horizontal line test. Okay.
Does that mean that it has to be in slope intercept form then?
No, because I can draw other graphs, and you're gonna see other graphs, and we're gonna talk about more definitions about 1-to-1. Okay, it does not have to be a line. We've already seen some graphs this year, they're not lines that are 1-to-1. X cubed, perfect example, yeah, okay. Oops, and B, obviously, go back,
Is a 1-to-1.
okay, B is 1-to-1 because it passes horizontal line, vertical line test. Okay. Good stuff. Okay, so some tests to determine whether a function is 1-to-1. You know, some of this stuff is directly out of a lot of this is directly out of the textbook, and sometimes it gets wordy and confusing, but as we work examples, I'll try to bring some of that together. Show that f of A equals f of B, that implies that A equals B. Okay, does that make sense to you? If f of A and f of B are the same, wouldn't A and B?
Is there the same?
Okay,
Yes.
it's an implication that A and B are the same. So f is 1-to-1. Number 2, in a 1-to-1 function, every y value corresponds to no more than one x value. To show that a function is not 1-to-1, find at least 2 x values that produce the same y value. Do y'all remember doing proofs in geometry?
Yeah.
Sadly,
I've
okay.
been thinking about this entire time. A equals B equals
Those
C
were the
and
words.
A
Okay.
equals C.
So, how do you prove something to be false?
You can't.
How do you prove something to be false? What does it take to prove something to be false? One counter example, right? So if I said, all the males in this room are intelligent, everybody say, what? There's Tyler, no, they're not, right? Counter example. He crossed his arms before I even said that. He knew it was coming.
I did.
Okay, so,
No, there's no.
Yeah.
There is no.
yeah, April Fool's, all males aren't intelligent. Okay, number 3, sketch the graph and use a horizontal line test. Number 4, if the function either increases or decreases on its entire domain, and that's where that x cubed comes in, right? If you graph y equals x cubed, that graph is increasing the entire time, right? So it never changes direction. It's never constant, it's never decreasing, therefore, it's going to be 1-to-1. All right. Inverse function, let f be a 1-to-1 function. Then g is the inverse function of f if 2 things must be true. So basically what we have here is we have 2 functions. I've got function f and function g. If f of g of x is equal to x, and g of f of x is equal to x, then it's 1-to-1. Both of them have to be true. Just recall that f of g of x, that means the same thing, and I prefer to write it like this. Okay, but it means the same thing. I'm going to take the g function, whatever that is, and plug it into the f function. And of course, this other one would mean g of f of x. Okay, I'm going to take the g function, I'm going to plug the f function into it, and if my end result is x, for both of these, then it's 1-to-1.
I actually did that wrong in the test. I was questioning myself so much on the test with that.
Okay, so here's an example. Write down those 2 functions. F of x equals x cubed minus 1. G of x is equal to the cubed root of x plus 1. And I want to know, is G an inverse of f? We have to check 2 things to see if this is true. I want to know, and I'll write it down this way here just so you'll continue to get used to it. I want to know what is f of g of x, which means what is f of g of x. So So I will take the f function, which is x cubed minus 1, and everywhere there's an x, I'm going to replace that x with the g function. So equals, there's an x. But g of x is the cubed root of x plus 1. So parentheses, cubed root of x plus 1 minus 1. Yeah, put that cube there. Okay, so here's my x cubed minus 1.
Do those cancel out?
What do you think?
Yes.
Lonnie, what happens when you cube a cube root?
It's 3, 9. That's my guess.
What?
I don't know.
I don't know.
When I
Tyler, what are
choose-
you thinking?
I think they cancel each other out.
Yeah, when you cube a cube root, they cancel each other out.
Oh,
So because you were right to begin with, Leilani, don't doubt
Second guess
yourself.
yourself when you end up with the square root of 3.
Okay, I heard it. I'm confused.
Me
What
too.
What are you confused about?
F of G of that. You
Okay.
don't remember? Yo.
So if I asked you what f of 2 was, what would you do?
Plug
You
it in.
replace
Plug what in?
Plug 2 in.
Into what?
for every x.
X.
For that x?
Yes.
So you would write 2 cubed, and to do it right, you should really put in parentheses, right?
Yes.
That's what you would do.
Oh,
Okay, we're doing the same thing.
What was G?
That is my x. So there's my x. It's the same thing as g of x. Well, g of x is the same thing as the cubed root of x plus 1.
So for we'll plug in.
So there's an
Oh.
x. So in place of that x right there, I put the cubed root of x plus 1, and that's cubed. Just like I plugged in a 2.
Okay, that makes sense. Thank you.
Okay? Anna,
yeah, I'm good now.
you're good now? Okay. Okay, so now we have x plus 1 minus 1, which is just x. Y'all are on fire today. Tell you what.
Oh.
Okay.
God.
So here's what happened. I took the f function, I plugged the g function in for x, I simplified, and I got x. Okay? Now, if I did not get x, I'm going to stop right now and say, hey, this is not 1-to-1. No sense in going on. But because I got x, I now have to check g of f of x because they both have to be true. So I now want to try g of f of x, which means g of f of x. So I want the g function, and anywhere there's an x, I'll replace the x with the f function. So the g function is the cubed root of, there's an x. What do I put in place of that x?
X cubed minus 1.
X cubed minus 1. So we have an x cubed minus 1,
Do yours cancel?
and then plus 1. Now, just as normal practice, when I'm plugging stuff in, I put it in parentheses. Sometimes the parentheses are useful, sometimes they're not. Do these parentheses serve any purpose for us?
No.
No.
Okay, so I can basically ignore them.
Yes.
So inside the radical, I now have the cubed root
0.
of x cubed minus 1 plus 1,
So they'll cancel each other
x
out.
cubed. Perfect.
Oh no.
And what is the cubed root of x cubed?
Max.
X.
I think that was really close actually. That was super
Okay.
close.
So we found that f of g of x was x. We also found that g of x of x is x. Therefore, by definition, is function f and function g, or are functions f and g inverses of one another?
Yes.
Yes.
They are inverses. Any questions, guys? None? Okay. Okay. There are two, what?
Sorry. I think I remember.
You remember what you did already? Mr. Hill, would you mind muting?
Seated.
Would you,
Oh,
would you,
yes, sorry
would you-
about that.
Hey, no problem, no problem. Okay, so here we have, letter A is a relation, F is a relation containing a set of points, -2, 1, -1, 0, 0, 1, 1, 2, and 2, 2. Is relation F a function?
Yes,
Is a function because
X does not repeat.
X does not repeat. Is relation F a one-to-one function?
No. Because 2 repeats in the comment.
Wait.
Why repeat?
Yeah, the Y.
Wait, what?
Confused.
Okay, about?
Mad respect.
I'm sorry. So if the x's, so in order for it to be a 1-to-1, there can't be any repeating at all.
Perfect.
Okay.
Well, you know, one can be an X, one can be a Y. X can repeat, Y can repeat. Okay, so we
Oh
look,
yeah.
so looking at those, do any of those repeat?
No.
Okay, so it
A
is
function.
Oh, hey.
a function.
But if it's, is it a 1-to-1?
Now look at these guys. What do you see?
It's not a
So
1-to-1.
it's not a 1-to-1.
The one
I see the
repeats,
ones.
And 2.
twos repeat. What's that tell us?
It's not
It's
a
not a
1-to-1.
1-to-1.
Not 1-to-1. The directions tell us to find the inverse of each function that is 1-to-1, so that one's not 1-to-1, so no inverse. Part B. Is relation G a function?
Yes.
It is a function. Is relation G, the function G, is function G 1-to-1?
Yes.
Okay, this is 1-to-1. So what's the inverse?
-3, -1, I don't know.
No.
1, 3, 0, 3, 2, 0.
What are you doing?
And flip that somehow.
You're changing the places of X's and Y's. Okay?
Of all of them?
Wait,
Okay.
what?
So this is function G. Function G is that set of points.
Yes.
I want to write the inverse of that, so I'm gonna write this G here. But I'm gonna write this thing that looks like an exponent, but it's not. Okay? That -1 that looks like an exponent is just how we indicate that we're talking about an inverse here. Okay? So the inverse of G is, and Hannah was exactly right, all you do is change places with the X's and the Y's.
Wait, what? I couldn't.
Okay? So 1, 3, 2, 0, 3, 2, and 0, 4.
That's gonna be
Perfect. Thank you.
Wow.
Have a good weekend.
Me too.
Okay. And if you wanted to rewrite that and put it in order, you could do that, but right now all I care about is, do we understand how to change one function to its inverse? And this is just done about the set of points. We swap X and Y. That's it.
That's the inverse.
That is the inverse.
If you put that on a test, I'll probably overthink and get it wrong.
Don't do that. Don't do that.
You make it so easy.
Yeah, it looks so simple.
Questions on points? Write the inverse of this. You can write it as a table if you want, or you can write it as a set of points. I don't care how you do it. Write down the inverse. Pens in math class, use pencil.
I've always used paper. It's habit.
How did you get through McGuff's class?
Actually,
Probably shouldn't bring that up.
they just pencil out.
This would go.
You know, sometimes we pass students because we don't want to mess with them again.
The
Huh?
shade.
Wait,
That's
you
what we
said
do
you
in high
could write
school
it in a
anyway.
table.
I don't
right?
want them again. Let them be somebody else's problem. I'll give you that
That's how
70.
I
See ya.
passed that class.
See ya.
Dude, you were failing so much because you never wrote your notes.
Yeah, so I never ever once showed wrote notes. I never like showed.
Would you write the inverse?
I can tell you they.
Mr. Hill doesn't want to hear
I
about
haven't,
your
I haven't
problems.
read it, so I haven't told you.
That's his one.
Okay, yeah, I see a lot of you are doing it with points. So f inverse of x is the set of points containing.
Oh, I didn't do.
You could have done it as a table, or you could write it this way. It doesn't really matter. And I just chose f of x because, well, it's just what we do sometimes. So flip them.
You said the negative one is the inverse sign, like. just
Yes.
like the-
Anytime you see what looks like an exponent of -1, we're saying the inverse. So 3, 2009, 12, 2010, 7, 2011, 10, 2012, and 2, 2013. And close your brace.
This is you. Look,
I thought it was funny that today's April 1st and we're doing lesson 4.1. I just kind of thought that was
I feel like this has happened almost.
I'm getting.
Yeah, we've done it quite a few times actually. Like we do it with the date.
It's actually April Fool's Day. So.
Did you fill in that?
Okay, equations of inverse. The inverse of a one-to-one function is found by interchanging the x and the y values of each of the ordered pairs. The equation of the inverse of a function defined by y equals f of x is found in the same way. So we're now going to look at doing equations. We were just doing points so far. Define the equation of inverse when y equals f of x. I'm going to skip down to the steps there. Step number 1, swap your x's and your y's. Step number 2, solve for y. Step number 3, it can't be y because y was the original function. Change that y to the inverse. And let's jump into one. Write down the function f of x equals 2x plus 5. And before we start doing math, is this a one-to-one function? And why? Mason?
It is a one-to-one function because neither the x or y repeats,
How do you know that by looking at the equation?
because it's not squared.
Well,
Oh,
x cubed must work also.
Or
What is it?
Actually,
We just won lost.
What's this graph gonna be?
linear.
Yeah, it's a straight line, right? It's a straight line with a slope of 2 going through y-intercept of 5. So is it one-to-one?
Yes.
Yes. Because it's one-to-one, can we find an inverse?
Yes.
Yes. How do we find the inverse?
So it's x and y's.
Okay.
Right.
So, if the f of x piece confuses you, go ahead and write it down as a y real quick. So I'm just gonna rewrite this. Y equals 2x plus 5. Swap the x and the y. X equals 2y plus 5.
So you don't switch the coefficients that are attached.
All we do is change the x's and the y's.
I thought you meant switch coefficients.
Nope, just swap the x's and the y's. And sometimes we'll come back to, we'll get to in a minute about that one.
Do more lessons this simple.
Huh?
We should do more lessons.
Yeah, this
simple.
is like so simple.
See,
My brain is.
We get into problems like this where there's multiple x's. What are you gonna do to the x's?
We can stay.
Can't
Turn them into,
Why? Why?
not a big deal. Okay, back to the problem at hand. Solve for y, what do you wanna do?
-5.
Plus.
Subtract 5. So x minus 5 equals 2y. What do you wanna do?
I don't know.
Don't divide everything by 2.
Oh, that works too.
Okay, so I have 1/2 x minus 5/2 equals y. But it can't be because y is 2x plus 5. But we will show that they're related. Okay, so I'm going to change that y to f inverse. Bring this guy up here. F inverse of x is 1/2 x minus 5/2.
Is it not the same thing?
You talking about these two?
It's the opposite.
I flipped it and put the function on the left side, but we changed the y to the inverse,
Do we have to write that, or can we? do it
Yes.
as a-
yes. Because you need to show, now if this original problem said y equals, then right here I would have written y inverse equals. But I'm showing that they're different.
Oh, okay.
This is the f of x function. The inverse of that function is indicated with that minus one up there. This is the inverse function to this one.
Yes.
Cassidy, you okay today? You're being very quiet.
Oops.
Oopsie.
We should be thinking.
Next function. Y equals x squared plus 2.
That's not a function. Huh? See.
Okay? So y equals x squared plus 2, that is a function.
No.
It's a function, we can graph it. What does it look like?
Parabola shape.
Parabola.
Oh, it's not a one-to-one function.
There you go,
gosh.
there you go. It's not one to one, right?
Bingo.
So this is a parabola opening, shifted, right.
Down.
Down. Oh, oh.
Hey, name all 4 of them, you're bound to get it right.
She said, oh. Or
You went like this. So I
No, I was hitting my forehead. We discussed with my bad hand.
Maybe you should not do that.
Okay, is it one to one?
no.
No, it's a parabola.
A function.
Okay,
It's a
it's
parabola.
a
Move
function.
to uppy.
Okay, no inverse. I won't put any of these on the test now, Mike. I don't know. Please do. But all the
Honestly,
test
do.
is
I
no
would
inverse,
think
no
I'm
inverse, no inverse, no inverse, no inverse. Done.
Please.
Then I'm gonna think I'm wrong. I'm gonna be like, there's definitely gotta be an inverse.
Yeah, I would overthink it.
April Fool.
April.
I could give y'all a multiple choice test, and at the very beginning, I could say that every answer is C. And there's gonna be some of you that would miss problems.
Yes.
Actually, I wouldn't be able to complete the test because I've been so long and being like, is it C?
Okay, letter C, speaking of C. F of x equals x minus 2 cubed.
Yeah.
What is the parent function?
Did you just say yes?
X cubed.
X cubed, what does x cubed look like? Hey, I'm seeing them drawn in the air. Yeah, okay, so I'm seeing that, drawn with hands through the air. Okay, is that one to one?
No.
Yeah.
Wait, yes.
It's always
Yes. It's all-
increasing. Okay, so by definition, this is in fact one to one. Just out of curiosity, see if y'all can screw this one up. How has this graph been translated?
It's
It's
translated
down
to the
to-
left.
Right.
No, it's been translated to the right because it's in the parentheses.
Right.
It's to the right because
Two.
it's inside the
Forgive them,
parentheses.
they don't know what they're doing.
Right.
It's to the right because it's
Right.
inside the parentheses. I remember.
It's to the right.
To the right to you.
Wait,
Wait, is it
but I
two?
thought it was down.
No, it's
It's on
right.
the outside.
That would be out here.
Yeah,
Has to be already
it's
known.
because it's in the
Oh,
parentheses.
Any parentheses and anything in the parentheses
Okay.
is the opposite of what you
Back to the problem.
It's a Friday.
I was like,
Okay, Thursday.
It's our Friday. I don't know what y'all are talking about, but it's our Friday.
What are they doing ending school on a Thursday on April Fool's Day? They're screwing with everybody. Okay. Let's find the inverse. So I've rewritten it. I've gotten rid of the f of x, changed it to y. Next step,
Change the X and the Y.
okay, this y becomes an x. This y becomes, this x becomes a y.
You almost messed up.
I do that all the time. Y'all got me flustered. I want y by itself.
Square
root.
Huh?
Square cubed.
Cube root both sides, right?
Throwback.
Cube
Oh.
root both sides, yes.
Cubed root.
What's too cute?
That's what I added.
So
It's
I
the
will
same thing as
take
square root, but with the cube.
the cube root of both sides.
ew.
That makes everything look complex.
which means we have the cubed root of x equals, and the cubed root of something cubed,
Y minus 2
y minus 2. I want y by itself,
Add 2.
plus 2.
add 2, so I have the cubed root of x. Folks, be careful with this, okay? When you're adding 2, make sure that 2 does not somehow get trapped underneath that radical sign, because that's wrong, okay? So plus 2
Like,
equals y. I added 2 to both sides.
okay.
Or you, I guess if you wanted to make sure, if you wanted to write that 2 plus the cube root of x, I'd be okay with that too. Okay. Now that I found y, I'm gonna change y to the inverse, so let's write the answer.
F of negative
Hey, look, you did x cubed.
x.
F inverse of x equals
Cube
The
root of
cube root
x.
of x.
cube root of x
Plus 2.
Plus 2.
plus 2,
On the outside.
okay?
Good job, Anna.
Thank you.
And again, that's why when I do radicals, I put that little tail thing down at the end to indicate that that is in fact the end of it. That one kind of messed up.
Fell short.
Dot.
There we go.
Shoot.
It's all fancy now.
Yes.
Alright. The following rational function is 1-to-1. I don't have to ask you, is this 1-to-1? Because they told us it's 1-to-1,
I don't think it's 1 1.
okay? They also told us x can't be 4. Why is that?
Because
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 if
of
x
the
was 4, the
denominator.
bottom would be 0.
Da-da-da.
Yeah.
Alright. Let's find the inverse. So f of x is y, 2x plus 3 over x minus 4. I'm wanting to find the inverse. What do?
Switch
Change
the x
the
and
x.
Okay, now y becomes an x equals 2
y plus 3 over y minus 4.
and from past experiences, this is where y'all start to fall apart.
Yes.
Thank you.
Don't know what to do from here.
I don't.
Multiply by
Add 4.
y minus
No.
4.
Why?
Because-
To get rid of the.
But
Get rid of the
not
denominator.
Wait.
Wait,
Okay.
but you can't though, because there's a y, and we're not supposed to have y's on the other
Okay,
side.
if you multiply through by a common denominator, what's gonna happen?
They can't.
All the fractions will be gone.
What?
Sometimes, and I'll change this back here in just a moment. Some people might want to, instead of writing x over there, they might wanna write that as, x over 1. Because now it looks like a proportion. And proportions can be changed really quickly to not being fractions, right? By
Multiplication.
cross multiply, right? So if we cross multiplied here, we would have x times y minus 4 and 1 times 2y plus 3. So if it's easier for you to make it look like a proportion in this case, go for it. Or if you want to multiply both sides by y minus 4, go for it. Guys, it's the same thing. Okay? What happens when you multiply x times y minus 4?
xy minus 4x.
4x.
xy minus 4x equals
2y plus 3.
2y plus 3. Folks, here's what we're doing. I want to get y by itself.
Subtract 3. Wait a minute.
Okay, so I want you to, okay, I'm hearing subtract 3. What are you trying to do by subtracting 3? Why do you want to do that? What would you do next after you subtracted 3?
Divide by 2.
Wait, where would you subtract 3 from?
They're wanting to subtract 3 from both sides.
Then,
Talk to me. No, talk to me. Go with it.
Wait,
you were on
no. We're trying to find x though.
No, we're trying to get y by itself.
Wait, could
Just
you also
divide
divide.
by.
wait, couldn't you also divide by x then?
From what?
Okay,
The
I will
xy?
tell you that most of the time when you're trying to solve an equation to get a variable by itself,
No, ignore
most
the
of the time dividing is gonna be like your last step. Okay?
Well, I'm gonna divide by y right now.
Okay, then you have y's and denominators all over the place.
No, they would count.
Okay, what's the problem?
Everything.
The Y is.
There's what?
There's two Y's.
There's two Y's, okay? What if we got everything that has a Y term on one side, and put everything else on the other side,
That's
Exactly,
that's
divide that by.
So I would go with that one.
okay? If you can get every term that has a Y with it on one side, we might be able to factor a Y out, okay? So, do y'all wanna get the Y's on the left side or the right side? I really don't care.
right.
Wait, the left to the right or the right to the left?
Left.
Which side do you want the Y's on?
Right.
You
Wait,
want the
no.
Y's on the right side?
Yes.
Okay.
Okay, I'm sorry.
Left.
Left.
See, I said left.
Left.
Okay.
Right.
Wait,
No.
I do.
I honestly don't know which one's
Oh
left.
yay, Mr. Rory.
I'm doing it the opposite way.
Okay. I'm moving the Y's to the left side. I now have XY minus 2Y minus 4X equals 3. I got something over there with the Y's, I wanna get rid of it.
Or X.
Add 4X to both sides. XY minus 2Y equals 4X plus 3. The left side now has two terms. Both of those terms have a Y in it. I wanna get that Y by itself.
Divide by X and Q.
Factor Y. Just
Factor the Y out.
Oh my god.
Okay. So I'm gonna steal that Y away, I'm gonna factor it out, so I get Y times X minus 2
Wait.
equals 4X plus 3. I want Y by itself, what do I do?
Divide by X minus 2.
It's that simple.
Oh my gosh, I'm getting a headache.
Oh, I like this.
So Y is equal to 4X plus 3 over X minus 2. I swapped X's and Y's. I got Y by itself, but we're gonna rename it. It's not Y really, what is it?
F of negative 1 X. Sorry.
Inverse of X.
Yes.
Bless you.
So we have F inverse of X is equal to 4X plus 3 over X minus 2. Do you see any problems that could exist with that inverse?
X cannot equal 2.
X cannot equal 2. So it's really important that you specify any issues with the domain.
Is that the answer?
I'm not gonna remember that.
All right, guys, it's 2:08. We've got a couple more slides left.
I'm gonna speed up.
We're gonna wrap up 4-1 on Monday.
Monday.
Monday, okay?
I'll see you tomorrow.
Tomorrow?
I'll see you tomorrow at that future work day.
Oh, the teacher work day tomorrow?
Yeah.
That doesn't
That doesn't exist because it's completely full of Mr. Barnes.
He fell for it, huh?
Oh man, fell for it so hard. He searched it and emailed for like 5 minutes. It was like, oh, just let us know how your teachers fall for that. Because I just fell for it. Miss Miller was just.
I forgot to sing all the headphones on.
Mr. Martinez is like, I hope this helps.
Diego, I have no idea how you wrap this up.
Don't worry, I had that problem too whenever I.
Yeah. Well, this is, this class works really, really hard. A lot harder than my other two. This one,
We can hear you.
you know, calm them down from time to time, but, second period are dead.
Aw, man.
Fourth period, I've got a couple jokers in there. This is a pretty good group. It's my biggest one too.
They do a lot of their own critical thinking, like all the input they're giving you. It's really awesome because they're gonna be good.
Yeah.
Yeah.
Hey, and I got a
I'm
question.
still trying to figure out what my class is.
Actually.
I'm very visual, right?
Right.
When they see
Actually,
Bryce, can you grab my phone?
Right.
no. There's a different reason. I know, I can
Wait,
tell
come
her.
here.
Y'all have a great weekend.
You too.
You too.
What's the,
Have a great one.
are you going to the next game?
You think that Mr. Coach Hinton will give me some ibuprofen?
I wish the swivel would have worked like it was supposed to, because it's kind of a nice, neat little thing, but
Wait,
for some reason it's not working.
No, it's okay. It's, you know, you basically, you got like 95% of the technology. And like, that's a good haul actually for any of these. I think it's hilarious. Every meeting with any sort of Zoom online that I've ever been to, you know, it's like, there's always something.
Yeah.
Something, you know, it's like, there's some sort of hex on technology.
Well, you know, I look around my classroom and, well, I use my own laptop. I have my own monitor. I have my own webcam on a tripod. I'm on my own iPad right now. I mean, everything technology-wise pretty much in here is mine. I don't own the Promethean board. That's about it. It's not mine.
Yeah. Like I was saying in the email, I just hoped, I felt bad because I meant to like, more like the beginning of last week, try to get back to you so that you could jump in on that, the application that I was talking about. But I hoped you got a chance to get in on that, so.
No, I missed it. I think the closing date was like the 26th, but
I will say it's one of those things that was only open for 2 weeks, which usually means they already have somebody in mind.
gotcha.
You know, I mean, at least that's been my experience, both sending out applications, but also, you know.
Yeah.
When I was a department head and we hired, that was the little thing, is that we have to put it up there, right? HR says everyone has had that equal chance and put
Correct.
it there
Yeah,
at least the amount of time possible. So,
right.
what do you call it? So that also, you know, I wouldn't feel too bad, but just keep looking, because I know that they're probably gonna need people, just because, what do you call it? I think it'll be interesting to see what they do in the fall. But right now the plan is they're going 50% face to face, but 50% still online. So depending on, you know, logistics, basically scheduling of classes and all that kind of stuff, they're probably, I mean, they just may need more sections just to make that work well. So yeah.
Well, I'd be interested. I just finished the online thing. It's in the final stages of Renita and everybody looking over it. But you know, I'd be interested in doing, you know, adjunct distant learning stuff on top of what I'm doing now, you know?
Oh yeah. They're definitely going to need that. Especially, they're definitely going to need that. It's kind of, I mean, I have to say, Zoom and Canvas works a lot better than I thought it would.
Right.
So it's, I was scared last March because I was, you know, like I've done online teaching and stuff. And I was like, this is going to be interesting. But they have some good technology. They have some good setups.
Right.
But yeah. Well, unfortunately, I gotta jump.
Okay.
Jump really quick. But yeah, I'll get that. I'll get that to you soon. I think it's due on your side. I need to get to you, so I'll just make sure I get it to you as quick as possible.
Okay. Yeah. Sounds great.
Okay.
All right, sir. Thank you now.
Good to see you.
You too now.
La verdad, ¿por qué? Porque hay pinche como
Can I borrow a calculator or are you using all of it?
Hey, social media.
I have the rabbit thing, but it doesn't work right. Can't do it.
Rabbit emu.
Press the alpha thing and it still just does that every single time. It's so annoying. I like rabbit.
That's the way
Hi, are you today, Mr. McGordy?
I'm well, how are you?
Maestro,
Thank you.
vamos a hacer el del jueves y viernes, o nomás el jueves.
Me?
I think you said teacher, and I think you mentioned a couple days of the week.
No.
Le pregunté que si vamos a hacer las de estas bonas del viernes, del jueves y viernes, o vamos a hacer. Pues no mames, ¿dónde salió tanto?
Well, I had that thing set up. I had a observation, had a guy that was on from Alamo Colleges.
Is that guy that we can reach his home?
Yeah, he was doing an observation on me.
So he's a cool guy.